Hello students, now we will study the second topic of the chapter electric charges and field, and in this topic we will study about electric field intensity, superposition principle, electric lines of force, their properties, dipole and dipole moment, electric field intensity due to dipole, torque due to dipole, and work done on an electric dipole. The electrostatic force acts between two charged bodies even without any direct contact between them. The nature of this action at distance force can be understood by introducing the concept of electric field. The figure shows a charged body produced an electric field around it. To understand this, consider a charged body carrying a positive charge Q placed at point O, and this is known as source charge. It is assumed that the charge Q produced an electrical environment in the surrounding space called electric field. To test the existence of electric field at any point P, consider a small positive charge Q0 called as test charge, because we are testing the electric field due to charge Q. So Q0 will be called as test charge and Q will be called as source charge. If a force F is exerted on the test charge, then we will say that an electric field E exists at point P. Electric field is said to exist at a point if a force of electric origin is exerted on a stationary charged body placed at that point. Quantitatively, the electric field or electric field intensity or electric field strength, denoted by capital letter E with vector sign, at a point is defined as the force experienced by a unit positive charge placed at that point without disturbing the position of source charge. As shown in the figure, suppose a test charge Q0 experiences a force F, then the electric field at that point will be E is equals to F upon Q0, or you can say by putting the value of force by using Coulomb's law, we will get E is equals to Q upon 4 pi epsilon naught R square R cap. In another way, the electric field at any point is defined as the electrostatic force per unit test charge acting on a vanishingly small positive charge placed at that point. Mathematically, E vector will be equals to limit delta Q tends to 0 F upon delta Q. In place of delta Q, you can also write Q0. Some important points about electric field. First one is, as the source charge is taken as positive, therefore the direction of electric field will be along the direction of electrostatic force. But if the electrostatic force on a negatively charged particle will be opposite to that of direction of electric field, as shown in the second figure of previous slide. Electric field is a vector quantity whose magnitude and direction are determined at every point in the field, and the SI unit of electric field is Newton per Coulomb, which is equivalent to volt per meter. And you know the formula of electric field, that is force upon charge. So by putting the dimensions of force and charge, you know force is mLT minus 2 and the charge Q. We have to find out by using the formula I is equals to Q by T. Therefore, in place of C, you have to write A into T. A stands for ampere Hence, the electric field dimension will be MLT minus 3 A minus 1. Now, let's find electric field due to a point charge. A single point charge has the simplest electric field. As shown in the figure, consider a point charge Q placed at origin and we want to determine its electric field at a point P at a distance r from it. For this, imagine a test charge Q0 placed at point P. Then, according to Coulomb's law, the force on the test charge will be 1 by 4 pi epsilon naught Q0 upon r square with r cap, or by replacing r cap by r vector upon its magnitude. Therefore, electric field strength will be force upon test charge and hence the Q0 will be cancelled out and we will get the electric field is equivalent to 1 by 4 pi epsilon naught Q upon r square r cap. That means by this formula we can say that the electric field due to a point charge has spherical symmetry. If Q is positive, then it is radially outward, and if Q is negative, then the field is radially inwards. And the variation between the electric field with the distance square is shown in the figure.